So what we're going to have you doing here is because there's a ton of different ways that graphs can be made. You can get ones that are really steep. You can get ones that are not steep at all. You can get ones that are like perfectly diagonal. You can get ones, of course, that are negative. Most of the graphs we've dealt with have entered through this point here, that 0, 0 line. Not every graph that we have done, though, has done that. If you remember, like sometimes when we talked about, hey, if you order a taxi, you pay a couple dollars up front, and then you pay for every kilometer that you drive. So you pay a couple dollars up front, and then it slowly goes up. So that's something where it doesn't actually enter what we call 0. And this is something that's called the y-intercept. We'll come to that in a second later today. But for now, I want to introduce you to a tool called DESMOS. Now, if you don't have access to it on the computer, you can access it on your phone. Do you have your phone here? Yeah. We're not actually going to be using a page right now. We're actually going to be using a website. We're specifically going to be going to something called, so it's DESMOS. It's something called DESMOS. So I want everyone just to navigate to that. Just go to your browser, put it in the search bar. It's DESMOS. And if you've done that, you should eventually end up at something that looks like this. It should be the top one, yeah. So it'll be desmos.com. And when you click on that, you should end up something like this. It'll look a little bit different on the phone, though. In fact, I'm going to navigate it on my phone while we're just so I have an idea there what that looks like. So DESMOS is a tool that you can use for a whole bunch of stuff. What we're going to use it specifically for today, we will be back to DESMOS later, is we're going to go up to something called at the top called Math Tools. Now, on your phone, you're not going to find that up there. Instead, you can click the thing that says Graphing Calculator. So you go to DESMOS, and then you're going to click on Math Tools and go to Graphing Calculator. Yeah. And when you do that, you should end up with something like this. Is everyone at a page like this? It looks a little different on the phone, but. Perfect. Yeah, that's exactly what I mean. So what you see here is they call this a coordinate plane, right? This is what we've drawn our graphs on. Most of the graphs we've drawn have been on this top right corner here. If I zoom out and move it a little bit, most of our graphs have been just on this section right here, on this top right corner. But technically, there's a whole, they call these different quadrants here. And so what you can do with this is I can put any equation I want. So I'm going to go to my workbook really quickly. You don't need to do this. I'm going to go to the last thing we worked on together. Here we go. The last equation we made was y equals 2.51x. I'm going to quickly put that in. Y equals 2.54x. And boom, this is now graphed. This is now graphed what we did earlier. So I put an equation there that y equals mx, m's our slope. That's that 2.54. And I ended up, it ended up giving me a graph. Is everyone able to like recreate that really quickly? Perfect. So there's a bunch of different things you can do with this. So let's say you want to add another line here. You can click on that add item, and that's going to add, and you go, you want to add an expression, technically, and you can now add something else here if you wanted. So let's say I want to do a different one, like y equals, I don't know, negative 1.5x. You get a different one. And do you see how the x like changes what it ends up looking at? What ends up happening with this blue line? So with Desmos, we can manipulate our lines. We can manipulate our equations to put the lines wherever we want, and we can actually see all the different points on it. Because if you remember, when we looked at this on, I think it was Monday, there's an infinite amount of points. There are millions, billions, trillions of points within here. The more you zoom in, the more points you get here, right? But if you zoom out enough as well, same thing. You'll eventually get the ones that go up to like millions. So there's tons of different points all throughout here. Y equals negative 1.5x. So, and so do you see how are you guys able to navigate the points as well? I know it's a little bit hard on the trackpad. What you do to get that is you just go on a line that you've made, you click and hold, and you can drag it all the way across. You don't even need to be on the line. You just need to be going up or down, as long as you're holding on. Is everyone able to do that? I don't know how that is done on the phone. Y equals, I don't know, 2x. Okay, on the phone, it doesn't work as well. Okay, there we go. Are you able to do it on your phone? Yeah? Okay, so that's the general like summary of Desmos for now. So what I want us to actually do is you get a little bit of time here just to kind of play around with it. Specifically, I'm going to hand this out in a second. We will work on this as a group. So if you're like, I don't know what to do, like I'm struggling, that's okay. I want you just right now, I'll hand this out in a second. I just want you to do your best. There's stuff that we haven't learned yet that this is an introduction to. So, but what I want you to try and do is I want you to just observe what happens as you kind of mess around with it. Like, what do you notice happens with the line? Like when I change the slope from like, 2.5 to, I don't know, a tiny fraction, for example. Like those are the types of questions that it's asking you here. So I'm gonna hand this out in a second, and I'm just gonna give you like, I don't know, something like 5 to 10 minutes to play around with it before we kind of come back to it, because this is leaning on to our next thing. So I want us just to have an opportunity to play around with graphs without having to draw 1,000 graphs. So as I go from a really small slope of like, this is 0.2 or 2 over 10, same thing. As that slope, the M gets bigger, what happens to my lines? It gets steeper, right? Yeah, it rotates, it gets steeper. So the bigger your slope, the steeper your line is, right? And doesn't that make sense? Because again, if you think about it as a fraction, if you have y equals 3x, this is technically, there's a little secret 1 underneath there, right? So it rises 3. So I'm going to get rid of every other line except for this one. So I can see that my graph here, it rises 3 for every 1 that it goes to the across. So the rise is 3, and the run, the one that moves to the left and right, by 1, which is also a hint for one of your question 2s there, because this point here is 1, 3, right? But yeah, so as you adjust your slope, your line gets steeper or less steep. It depends on how big it is. So I'm going to give you a couple of minutes to work on question 2, and then we'll go through that in a second. Yeah, there's a negative there now, right? Which isn't something we've had to do before. But what that means is, so if I'm doing 3, oops. So if I need to try and make a line that goes through 3, -9, that's all the way down here. I need to get a line that's going to go through that. So the second there's a negative, what do you think that has to do to our slope in order to do that? Well, I get what you're saying. Yeah, close. You're really close. I think you just need to word it differently. So remember, when we read our graph from left to right, a positive one goes up. So y equals, if it's a positive number, as you go from left to right, it goes up. If I make that a negative number, as you go from left to right, it starts going down into these negative points here. So what you need to do is you need to try and get closer and closer there with negative numbers now. In this case, you know it's eventually going to end up being negative 3x. Because in this case, as you get a bigger and bigger negative number, same thing, it gets steeper. It just gets steeper in the other way. Yeah, so y equals negative 3x is eventually going to get you into those negative points there. Where this stuff gets really, really difficult is question E and question F here. So if you guys are looking at this one here, in this case, I don't want you to get a line through 1 point. I want you to get a line through 2 points at once, 0, 5 and 0, 6. Oh gosh. So if I want you to get through, is that 0, 5 and 0, 6. So in this case, I want us to come up with a line that's going to go through both of these at the exact same time. Now, without even telling me like the math part of it, what's the easiest way to get a line that's going to go through both of those? Oh, so sorry, there's two people talking there.
It's 0.
So something that's going to make our x equal 0?
Yeah.
So this is something we haven't learned before. Mm-hmm. Oh yeah, that'll work because that's oh, this one to oh we're on E right now, but for 3 to negative 9, that one.
Number 3 is up here, and then negative 9 is over here. Right?
Well, so if it's 3, negative 9, we're looking at like this point right down here. Remember, you're plotting that in there. Well, I'll deal with the negative one later. Right now, we're on question E. It's going to get more confusing if I jump around from one question to another. So in this case, I want to get to a point that's going to go through both of these. So that looks like something like this. So we haven't learned how to do this yet, but wouldn't I just need a line that just goes straight up? You need a line that goes absolutely straight up. In this case, you can kind of, so this is where the cheat code I was mentioning starts to come into play. I can just say that, so in this case, the x in both of these is 0, right? Why can't I just do x equals 0? If I do x equals 0, I now have a line. Make that a different color. I now have a line that goes through both of them. That's the cheat code from before. So if you have x equals 0, it doesn't matter what your y value is. Every single time, it's always going to end up on that 0 part of your axis. So it's always going to be 0. So if you have x equals 0 as your line, you're going to go through both of those. So I'm going to quickly plot these. So it's 3 and 5. So 3, 0. Oh my gosh. Three, 0. Gosh. Perfect. And it was 5, 0. So yeah, that's exactly it. You'd put y equals 0 there, right? Because for both of these, the y of these is 0. So I kind of just have a line that goes through all of this. So we can change our line a little bit. We can change our equation a little bit to do a whole bunch of stuff. So in this case, if I want my x equals 0, I would just literally put x equals 0. So what's different about these two equations? Any guesses? What's different about question E and question F compared to all of our other ones that we've done? Any guess? What's missing in these two equations that we have in these ones?
I can look. Select Y.
So a couple things. So yeah, well, the fractions, the x and y is correct, and the slopes is also correct. Technically 0 is a slope, but like I know what you mean. Like there's no slant, there's no diagonal in any possible way. So yeah, it's missing both the x and the y, and it's missing a slope. That's what's different about these two ones here. And then for the third part here, so we wanted to plot this equation, y equals 3 over 2x. So everyone go quickly do that in your Desmos. Everyone go quickly plot that. Y equals 3. Put your little slash. 3/2. And then x.
Y equals 3 over 2x.
Y equals 3 over 2x. Yeah. Yeah. And again, to put that in as a fraction, you want to use that little slash button. Cool. So thanks for helping out there, Jasmine. So we have y equals 3 over 2x. Cancel. So what it wants us to do is it wants us to know is what happens if we add 2 or we take away 2 to those. So what happens with this line the second I do this? Oops. Plus 2. 2. It rises, right? The line itself just moves up. The slant doesn't change, the slope doesn't change, it just moves up. So if that's the case, I'm going to put all three of these. Y equals 3 over 2 plus 2. Oops. Plus 2. So what do you predict is going to happen when I take away 2 then? What do we think is going to happen when I take away 2 now? If it rises when I add 2, it's going to drop. That's exactly it. Oops, 3x. Oh, I forgot the x here. No wonder. There we go. So it's the same line. The only difference is when I add the 2, the line moves up on the plane. When I take away the 2, the line moves down on the plane. So this is what we call like a y-intercept. That's something we're going to deal with a little bit more tomorrow. So someone answer this question to me. What happens when I add the 2? It rises. Yeah, it rises. What happens when I take away the 2? It lowers. So what do you think adding or subtracting a number from this does? So when we add or subtract something from our equation that we've used the last 2 days, what does it do? In your own words, I want you to write that down. You don't need to actually tell me. I want you just to write down in your own words what you think happens there. So when you add or subtract a number, in this case, we picked 2. What happens to our lines here? So in your own words, I just want you to write that down. Yeah. So you're looking at when it like crosses this line here? Yeah. Again, we'll learn a lot more about this maybe later today, but definitely tomorrow about what these twos do. But yeah,
So it's so two.
that's a better way of wording it. That was a better way of doing it. Why didn't I think about that? Okay, so if you finish that, cool. You're welcome to like hand that in at any time. If you still need more help or more work on it, I'm happy to help you out with that through like later today or like in later this week. That's okay. I know I kind of threw a lot at you very quickly there. We will learn more about this tomorrow and maybe tonight as well. I know Morgan's gonna have a little bit of like a presentation for you lovely folks here. Just gonna